They're all verbs. I need a verb. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Dan Maloney.
This is episode 301. We'll be talking about hacking NVMe into Raspberry Pi, lighting LEDs with microwaves, and how to keep your fingers. This week in Hackaday news, we've got more Major Tom news, right?
Yeah, the stranded astronauts, their days of confinement will continue. They've been on there for, since August, I think? I think that's when they first got up there, and then their janky ride home didn't make the grade, so that thing went home without them, and then they said, well, we'll pick you up in February, and now they're like, maybe March? Sounds more like it.
Oof.
They've got to do some more integration of the Crew Dragon that's going to go up and pick them up. Apparently, there was some sort of delay in the shipment, and it didn't get to Kennedy Space Center until just a few days ago or something like that. So they need more time to do the integration and blah, 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 blah. So these guys have to stay up there for another month, which at this point is probably nothing. But, I mean, they show pictures of them, and they're all smiles and everything. Hey, here we go. Day 398 or whatever it is, they're on the space station, and they're all smiles, and I just have to imagine as soon as the camera goes off, they're like, oh,
yeah,
not happy about it. You can kind of tell.
Yeah, I don't know. I mean, these people are astronauts because they like being astronauts. Maybe they like being in space.
Oh, I would assume they do. It's just that, they're missing, birthdays and graduations and stuff like that. And that's gotta hurt.
Yeah, I think you probably want to be home when your time to come home is that. I can believe that, though.
They'll get there eventually. I mean,
SpaceX launched the rescue mission on Saturday with a downsized crew of 2 astronauts and 2 empty seats, but for some reason they're not.
That ride doesn't have the adaptations for their spacesuits that they've only got their spacesuits that were compatible with the Orion. I think it was Orion, right? And so now they need some sort of adapters now.
I suppose that's right. I mean, there's a whole different infrastructure in the capsule, probably. Oh, God.
But there's also the fact that Apollo 13 managed to build an adapter between the air scrubber cartridges, and when they were on the far side of the moon, they were able to do that with notebook pages and duct tape. So I'm thinking, could maybe cobble something together faster than that?
I think you only cobble when lives are at stake. I think if you've got plenty of time and they've got plenty of food and, they're just chilling out up there. It's not yet time for cobbling. Not yet time to break out the duct tape. And when it is, that's like time to break out the diapers and the duct tape. Yeah, it's funny. Tom, our resident space nerd, was saying that there are all sorts of adaptations of the capsule that are specific to the people riding down. And actually, especially on Soyuz, the seats are like custom made for them. And like you can't just go up and down on any Soyuz capsule. Each one has like a custom personally fit seat to each pilot, and so they don't just like run them up. It's not like you're just sitting down in a car. It's got to actually support you for the rapid deceleration.
It's not just a comfort issue. It's like, you'll turn to jelly if you don't have the right seat.
Yeah, it's like the egg drop things.
Right. A bunch of soda straws, right?
Yeah, exactly. I guess all that, it's what they say about space stuff, is that it's much more complicated in many more ways than you expect. But so here we are with yet more of them. I guess I shouldn't be surprised.
Not surprising.
This is a journey into sound.
What's that sound?
What's that sound?
Well, you want to try out a What's That Sound?
I will give it a try.
I heard this one last week, and I've been dying to get a chance to run this one.
Oh, I don't know what that is, and I don't like it.
Really?
What the? That's real creepy sounding. If I heard that in the middle of the night, I would... Wow. It sounds like an animal call of some sort. What specific animal that is, I don't know. It doesn't sound like a fox. I know what a fox sounds like. They make a weird noise. No clue past that. And some sort of nocturnal mammal.
Not bad. Hope our listeners have such a good guess. If you do, head on over to hackaday.com/podcast, scroll down to What's That Sound, fill in the form, and we'll see who gets it right next week. All right, well, let's start up the hacks. I wanted to start off this week with a bit of a sleeper. Where this Christmas card's going, we don't need batteries. It's an energy harvesting light up LED Christmas card. And I thought that was pretty cool, but then you start digging into the project and it gets deeper and deeper and deeper. And so this is Jeff Keecher's Christmas card for this year. It's almost the size of an index card. It's got a picture of a Christmas tree on it with some LEDs and then what looks like a little, squiggly wireless antenna patch. And of course, that's the secret to do the energy harvesting. And the first demo on his webpage is him holding it up to a microwave oven and baking a potato in the microwave oven and the LEDs light up. So it's working on just the leakage current, which gives you the first hint that it's at a 2.4 gigahertz frequency. The thing's tuned for 2.4 and runs on a few microwatts. But then you got to follow the rest of this page. You got to click on through the technical info, and the rabbit hole just gets deeper and deeper and deeper. I mean, the circuit's kind of what you expect it to be. It's the antenna and then a couple capacitors and a bunch of diodes to rectify it, right? Like, there's nothing particularly freaky about this, but all the parts are picked very carefully to be like super low leakage on the diodes and et cetera, et cetera. I mean, that's pretty cool by itself. The microwave oven example is really neat, but then he also demos that it can run on just the ambient power from Wi-Fi. He manages to make LEDs blink running off of his house's Wi-Fi router, which I think is really cool. And of course, if you want it to light up brighter, he says you run a speed test, right? And so you send out lots of packets over the router. And then he gets to thinking, now wait a minute, I can use the amount of traffic on my house's Wi-Fi network to send information to this device. And so he writes up a remote control web page that does a lot of traffic and then doesn't do a lot of traffic and then does a lot of traffic and doesn't do a lot of traffic and does kind of amplitude shift keying to send data to this card. So he's turned the card into not just a power harvester, but kind of a Wi-Fi RFID ungodly mashup. And that's really cool. And then it turns out it not only harvests power from the 2.4 gigahertz, but he actually picked the LEDs on it, especially to be LEDs that behave basically as well as possible as solar cells, right? Like, so, like everything, you can run it backwards, right? So you put electricity into an LED, it makes light. You put light on an LED, it makes a tiny, tiny little bit of electricity. But here he's actually using the LEDs when he's not blinking them to collect a little bit of power, and he's storing that up. And all of this goes into a super cap, and this is a really, really cool project in terms of a very refined power harvesting setup. At first the gag about lighting up your Christmas card on the microwave oven is pretty cool, but if you dig into the technical details here, this is actually like a stellar hack.
Plot twist, you do this, you send your kind of neat techie Christmas card out to your work acquaintances and people in other companies and all that stuff, but actually it's sitting there waiting to exfiltrate data over that amplitude modulation sort of scheme. If you've got some, if you got to have an exploit on the routers, obviously, so if you could do that, you'd probably get your data that way. But still, it reminds me a little bit of, what was it, the Furby problem, where people were bringing Furbies into the NSA and the CIA, and they were repeating back state secrets and stuff like that. Maybe this it looks like it's just an innocuous little Christmas card, but it's actually a super duper exploit.
No, I think it's just really fantastic. And of course it doesn't have to run all the time. It's not blinking LEDs continuously. And so there's some clever software here on the little PIC chip that he's got running the brains for this too. That's just such a cool project. This is the Christmas business card hack that I want to receive. This is pretty awesome. So hats off to Jeff Keecher for this one.
All right, first up for me, Automated rig grows big, beautiful crystals fast. This one's from Les Wright, and I hadn't heard anything from Les for a while. Usually is pretty regular about releasing videos, but I'd noticed it had been a while, and then this video dropped, and I could see why. He had his hands full growing these amazing and gorgeous crystals that he needs for his laser experiments. These are potassium dihydrogen phosphate crystals, which if you grow them big enough and optically clear enough, it's a nonlinear optic property of the crystal itself that it can frequency double laser light. So I guess frequency doubling would be having the wavelength, right? He actually dabbled with this a little bit earlier and grew what I thought at the time were amazing crystals, but the current effort dwarfs those first stab crystals. The video has an awful lot of information about growing crystals, and it gets down into the real technical details of crystal growth and how things are done and the different chemicals you would use in different conditions and all that stuff. And it necessarily had to go through all of that to figure out how to make these ginormous crystals. So you can kind of speed ahead in the video if you're not necessarily interested in that and get to the part where he actually makes the rig, which is pretty simple. It just took, a lot of work to get it simple. It's one of those things. It's enclosed in an old server case, an old server enclosure as a kind of a temperature and, environmental cover so that there's not dust getting into the supersaturated solution of potassium dihydrogen phosphate. The crystal forming part itself is basically an armature that spins inside of the supersaturated solution. He had to be really careful about the surfaces of everything that touched the supersaturated solution. You couldn't have, rough areas that would sort of provide a nucleation site, and you'd grow a crystal where you don't want to grow a crystal, or you'd have imperfect crystals and stuff like that. So a lot of careful engineering, a lot of careful construction methods to make all of this stuff. He basically ends up making seed crystals, which themselves are pretty big, and I would be pretty impressed if I could make a crystal that big. And he uses those on the armature, puts this in the solution, and he's got a whole automated regime of temperature changes, profiles, and he needs to ramp up the temperature. It's a little bit like loops that control like hot plates and SMD soldering and stuff like that. But he says he doesn't use any closed loop, he doesn't use any PID software. He said it wasn't worth it for him to implement that. He could actually just do the D part of PID just by manually switching on and off the hot plate that keeps this thing warm. And basically the stepper motor spins this armature to make sure that you're always getting fresh solution onto the growing faces of the crystal. And after a week, he was able to grow doorknob-sized crystals, 40 grams of optically pure KDP and these fantastic crystal shapes. The photography is just gorgeous. He's really upped his production values in his videos, and I talked to him a little bit about it. And he says, "Oh yeah, I just added a few lights from Amazon, and it really makes a big difference." And it does, because it's the crystals really catch the light. They're just gorgeous, and they're big enough for what he needs to do. Cut them, polish them, prepare them, all that stuff, and that's to come in the future. I'm sure he's diligently working on that right now, but just gorgeous. And like I said in the article, anyone who's ever tried to grow up like a crystal garden or tried to make rock candy in the kitchen knows that it's not easy to make even crummy crystals. But he's managed to make these gorgeous, beautiful, optically clear crystals, and it's quite an achievement, I think.
Like, we've done the grow alum crystals with my son and stuff, and we got for us some pretty awesome ones out of it. But they're they're kind of penny sized, and these are, like you said, they're doorknob sized. You can hold one of these in your hand, and they're just so beautifully clear. It's really unbelievable. And I always thought you had to keep your crystal growing whatever, really still so that it doesn't get shocked, so that it doesn't move. And so I was surprised to see that this is spinning in a continuously agitated bath. It's got one of those little magnetic stir bars in it. And like you said, it's all rotating on this custom 3D printed platform. So it's continuously being exposed to fresh solution, which I guess is the point if you want to maximize the speed. And the other thing that I didn't know about this, and this is the whole point of the temperature control and stuff, is that there is kind of, and I think it depends on what crystals you're trying to grow, kind of an optimal schedule for changing the temperature so that it stays kind of just on that edge of being super saturated all the time. And so like he's lowering the temperature, and then some of the, whatever it is, potassium diphosphate will glom onto the crystal, right? So there's less of it in solution. And so he's lowering the temperature constantly throughout this profile as the solution gets less potassium stuff in it so that it keeps it at the same just super saturated state. So it's like always maximally crystallizing. And I think that's the part that was really neat for me here, was seeing, just this idea that A, you can move it, and B, exposing it to new solution is probably good, and C, thinking about controlling the temperature, but that controls how much of it can stay dissolved in solution. Really, really cool. I'd never thought about kind of, commercial industrial scale crystal making. But like everything here it's extremely well done, but it's all also kind of simple. Like it's a 3D printed rig, it's a stepper motor, it's an Arduino to control the temperature, and the temperature, like you said, it's a slow enough system that it's just bang bang, it's on off, and it's a pretty simple system, but the results he gets. And granted, he shows all of his failures too. He's like, oh, and this is the time where, there was too much dust in there and it just like explodes in all of these little microcrystals all on the inside of the beaker. And that's really cool too. The time lapses of the ones that work are just stunning.
Yeah, that was the real value added part here, because he kind of he did almost like an octoprint sort of thing on his rig, and got a webcam, and then coordinated it with the rotation of the armature so that he took a picture at specific points when the armature is in a specific point, and then it just looks like the crystal is just growing out from the seed, and gorgeous photography. Hats off to Les for coming up with this and sharing it with us all.
All right, well, next up from me, enabling NVMe on the Raspberry Pi 500 with a handful of parts. This is funny because on last week's show, we were talking about how Jeff Geerling had taken apart one of the brand new all-in-one Raspberry Pi 500 little standalone computers. And these things are really cute. It's basically a keyboard, and they have managed to take enough space inside it to wedge a little computer in there. Compact keyboard form factor, but with the Raspberry Pi in it. Really fun. Because the Raspberry Pi 5 is capable of doing a lot of PCIe, the question is why not put a slot for like an NVMe hard drive in there? And that would be absolutely fantastic for this little one-piece self-contained computer unit if it could also have a real solid-state hard drive on the inside. And so it's kind of the obvious thing, and it's clear that the hardware could do it. So Jeff's video last week was, why can't you do this? Because he opens it up and there are tracks there on the PCB, but it's not populated. And so he gives it a first attempt at hooking it up and can't make it work. And that was the subject of last week's video. And I'm like, oh, give it a week. Somebody will get this done. And lo and behold, a week later, Cucumber writes to Jeff and says, hey, I got it done. It works. And all it took was connecting the lines up, basically. So it looks like the Raspberry Pi folks got that close to a working NVMe M2 solid-state hard drive solution and then just bailed out at the last minute. And of course, there's tons of speculation in our comment section about why they bailed out. My guess is it's a power supply issue and they don't want to like brown out the line to the solid state drive, because that would be bad news, I think. I don't know how gracefully they fail when their power falls low. But basically the hack consists of soldering the M2 slot on there, soldering 4 caps, 4 tiny little 0402 capacitors to connect the lines up, and then providing it with a 3.3 volt power supply. As Jeff conjectured, everything is there to do it. It's just a question of getting the power to it. Another hacker, Elias RM, came up and found a voltage regulator chip that he could get on the board, and so has an actual all-in-one solution for this. And there are details about that in the post too. 1 week ago, it was like, oh, this should be done. And then this week, ta-ta, done.
We get results, or Jeff gets results. It's funny that we've come full circle on computers, where the first computer I remember, really coveting was the TRS-80, which was what? It was a computer and a keyboard. C64, computer and a keyboard. Apple II, a little bit bigger than that. Keyboard on steroids, but, it was basically that sort of form factor. And then we got away from that, and then the keyboard just became a thing, and now we're coming back around to realizing, hey, it would be nice to have everything right in one package and just connect it up to a monitor. And it's nice to see that this is possible. I'm kind of looking at the PCB pictures and just goggling at the tininess of everything there. I mean, if I'm not mistaken, that's a mini SD card slot at the upper right of that, which kind of gives me the scale for everything else on that board, which is not even grains of sand, half grains of sand. All right, next up on my list is homebrew electron beam lithography with a scanning electron microscope. This is another of the sort of general topic of semiconductor fabs in the garage, and we've seen decent number of these efforts. Ben Krasno did that for a while. I think Jerry Ellsworth did some, made her own transistors in the lab. Sam Zaloof, of course, and we've seen a bunch of efforts along this lines. And the thing that always impressed me about those efforts is they really need a lot of equipment to do the usual sort of photolithography steps, where you coat a substrate, silicon generally, or silicon oxide, with a photopolymer, and then you expose it to UV light through a mask that generates a pattern. You remove the unexposed areas, you etch it with nasty chemicals, and you keep doing that until you build up all the layers of your circuit. And that's great. It works. These chips are not going to rival anything that comes out of a commercial fab anytime soon, but the fact that someone is doing it at home in the garage is awesome, and I love these kind of stories. But everything seems to be really expensive. Vacuum chambers, tons and tons of stainless steel, piping, flanges, bolts, instrumentation up the wazoo. Everything is super, super complicated and expensive. I think Peter Bosch found a way around a lot of that by saying, all right, I'm not going to do photolithography. I'm going to do electron beam lithography. And you say, well, that sounds even more complicated than photolithography. And but if you buy a scanning electron microscope, you've got basically the whole kit in one package. You've got a vacuum chamber, because scanning electron microscope sample goes into a vacuum. And so you've got the pumps that go with that. You've got an illumination source. It happens to be illuminated with electrons instead of with light. And you've got a place to put a sample and a stage to control the sample. All that's important. But this scanning electron microscope that Peter picked up did need a little bit of modification. And I'm not trying to say that it's trivial to go out and buy a scanning electron microscope and bring it home and get it working, but it's not impossible. Peter's done it. Anyways, to make this whole thing work, there's a fair amount of chemistry. You still need a resist layer. Peter chose PMMA, acrylic, basically. It was kind of neat what he did. He basically just started breaking up pieces of plexiglass and throwing it in solvents and seeing what solvents made an appropriate viscosity of liquid polymers. I think he tried acetone at first, and it just made it too runny, and it wasn't useful. He finally settled on anisole, which is basically a perfume base, smells like anise, but it's also a really good solvent, organic solvent, and that actually worked really well. Made a syrupy enough PMMA solution that he could spin coat it with this janky little, basically a PC fan spin in with a glass slide on it, and it just did the spin coating real quick. He got that and sorted out, and then he needed to figure out how to vector the electron beam over the sample. A scanning electron microscope generally rasters, so it's like it's just like a CRT. It's basically a CRT tube that you can open up and put something inside. It's got an electron gun on one side. It just doesn't have the phosphors. It's got basically all those guts, but it's designed to raster over the scene. He didn't want to do that. He wanted to do something more like a laser cutter would do when it's cutting out circles or squares or some sort of shape that you put in from Vectorworks or something like that. He wanted to do, an XY sort of control. he had to add a card or interface for external deflection to the microscope, and he just sort of brushed over that. I think there's a really good story there, and I asked him, please, can you share that story? I think, modifications to a scanning electron microscope might be right up our alley. And he said he might get back to me on that. But he is a physics student, so he's got to finish up his PhD first. It's more important. But anyways, he was able to do exactly what he wanted to do, and the results were pretty spectacular as far as resolution and the sort of the crispness of the whole pattern that he etched into the substrate. He didn't use silicon on the first go. He just basically used one of those aluminized mylar space blankets as a substrate, because he's still working on ways to metallize substrates and all that other stuff. But the results on this aluminized mylar were really, really fantastic and very promising for the future. And I'm really keen to see where he goes with this. If he's going to try to etch silicon directly, or silicon oxide, he needs to put oxide layers on and metal layers. All that stuff is to come. But this is kind of almost a lab in a box sort of thing with the scanning electron microscope, but obviously still a lot of external peripherals required, instrumentation and all that stuff too. But looks like he already pretty much had that stuff on hand. So
I love how you started this off with, rastering electron beam etching shouldn't be that hard if you've got a scanning electron microscope to start with.
Yeah, well.
Right? I mean, you've got something that shoots electrons. You can steer it. You're good. You got high vacuum. Everything's squared away. Yeah, why don't I just go down to the basement to my scanning electron microscope? From previous Hackaday Supercons, and actually he was going to bring one this time but couldn't get a machine that was both working and portable enough. Adam McCombs is a serial electron microscope harvester and repairer, and has given a couple talks on it. I'll put some links in the show notes for you. But his point when I was talking to him about it is that a lot of these scanning electron microscopes from the 80s and 90s, all of the mechanical stuff, all of the real physical parts of it are about as good as the more modern ones. It's just all the driving hardware and software that goes with it was archaic. And on the other hand, that makes it super easy for hackers to get in and fix the thing back up. And so Adam's point was that right now you can find discarded scanning electron microscopes that are in working shape or nearly working shape, where the only things that are wrong with them is probably something in the driving circuitry that you can replace with an Arduino. And now is the time where these are all showing up on the loading docks of universities everywhere. If you want a scanning electron microscope, now is a good time to be looking around for them, because this kind of last wave of 1980s, 1990s SEMs is out there and are probably about as hackable as anything you'll ever find again. So if this is your sort of thing, get on it. And man, it makes me jealous. They're really fun.
Yeah, and then maybe you make your own chips too.
I just want to look at stuff. All right, last up from me, PCB motor holds fast even after 1.6 billion spins. This is a great video from Carl Bujega, who has been working on making PCB motor designs for the past 6 years. He gave a great talk at SuperCon ages ago. Must have been 2019, 2018. And I got to interview him there. We talked about this project for a long time. And this is just like a long-running labor of love of his. This video is introducing a new motor design that he's got. It's extremely refined. He's got plans for it up on GitHub, but I think he's also selling them. The video is kind of a review of the last 6 years of work he's been doing on this front, and it's really neat to see. The new one spins at something like 30,000 RPM, and the point of spinning them for so long was that he was doing stress testing to make sure that the ones he ends up selling actually work for something. And he's got this really great rig. It's a wooden box with a bunch of sound padding in there, and then 6 or 8 of these tiny little PCB stator based motors running in there, and they're pretty noisy spinning at 30,000 RPM, but he just fires it up and puts the lid on the box and walks away. The video talks about, all of his design trade-offs that he had to make. He's using the copper on a PCB to make the coils that then pull against some fixed magnets to make the motor work. It's, like any old brushless motor, basically, except the coils are not wound. They're just copper traces on a PCB. The trade-offs here are how you do turns versus thickness of the coils versus geometry of the coils and all that. And he gets a little bit into that. In this refinement, he actually ends up running into a whole bunch of physical constraints. Things like how to get the magnets right. He has the shafts in there, and originally they were metal, but then he started using nylon screws. You don't want eddy currents being induced in the screw holding the thing together. They end up not being strong enough, so he has to go to stainless steel. One of the real game changers for him with this design was actually that he switched out to ceramic bearings. Before it was running on metal bearings, and he had to use 2 of them, and they had too much play, and there was a little bit of loss there. Even though they were stainless, there's a little bit of loss to eddy currents in them. Required lubrication. Ceramic bearings solve that problem, and how they're a little bit more expensive, but they let him make them even flatter. He moved from a 4-layer board to a 6-layer board, but this let him put all of the driving electronics for the brushless motor on the back of the brushless motor itself. So these are really cute. I guess it's the size of a quarter or so, 4 mounting holes, and then the front side spins and the back side has the driver on it. So it's a tiny, tiny little flat brushless motor. Really, really cool. And just love seeing all of the design challenges and the engineering and the progress he's made on this.
I can't believe it's been 6 years since he's been doing these PCB motors, because I can remember those first, the first ones that you were pointing out, and they didn't do anything really. The fact that they turned at all was just enough. The different ways that Carl's branched out from that initial project and kind of capitalized on some of the concepts, like the coils. He's made other actuators based on those coils, based on that whole printed coil technology. He got into the flexible PCBs, making things move that way. All of these things are steps on that journey, and I appreciate when he puts out something new like this and shows us gee whiz things, and then get you thinking about what you could use it for. Okay, last up, if you want to get creeped out about the AI future we're all forced to live in, read See What They See in Your Photos. Lewin wrote this up, and it was a little surprising because Lewin's picture appears right in the front of it, but there's a good reason for that.
Exactly.
Because there's a website called They See Your Photos, and the link to that is obvious. You can find it in the article, or you can just plug it in yourself. And basically, it's a very spare interface that you plug a photo in, and it tells you what the photo is all about from sort of the point of view of Google's Vision API. So it tells you a whole bunch of details, and the reason that Lou included a picture was that this is the one that he used as a test image. It's very weird. The tool works by basically, looking at the image and then describing in text what it sees. And for Lewin's image, it kind of described the setting. You could see trees in the background, and you can see Lewin in the foreground, and it describes Lewin in general terms. It said it's a, young to middle-aged Caucasian male with shoulder-length light-colored hair. He seems serious, perhaps pensive and slightly uneasy. And it goes on in this way for a whole paragraph. The creepy part about it is it's telling you what it thinks is important with its descriptions. So it's telling you that it's his approximate age group, his approximate ethnicity. Honestly, the color balance on the picture is really weird. It's yellow-green sort of cast to it. So, his skin color is completely off from what Lewin actually, his skin tone is in person. But it's still, from facial features and stuff like that, it figures out he's Caucasian. It figures out, what color his hair is. It kind of gets some information about what his state of mind and state of station in life is. All these things, which I thought were really creepy at first, but then later on in the comments, saw Elliot's comment about, well, yeah, of course, that's what it's going to tell you because that's how they sell you stuff. So those are the kind of things that Google wants to pull out of a photo when they're parsing it to see if you could be marketed to. So they know now from Lewin posting this picture I'm sure they knew this well in advance of that, but they knew his approximate demographics and what sorts of things they can market to him because he fits into a group that is discernible from this photo. But of course, I had to give it a try. Spooled up, they see your photos, and I tried to pick a picture of me that was as non-identifiable as possible. Had a picture of me with those magnifying eyeglasses on. You know, they got the two loops on the lenses. So completely, I just had one, around. So I was like, okay, that's relatively innocuous, and I loaded that one in there. It correctly figured out, it described the scene. It was a picture of me, a selfie in my kitchen, and it figured out from the blank wall behind me that we have modest middle class home. It figured out, actually underestimated my age. It put me at middle age or something like that. And I'm like, I'm a little older than middle age at this point, but wearing magnifying glasses, it implies a serious situation, perhaps doing small work or focusing on something intently. It seemed to be very concerned with skin condition. Every time I put my photo in, it was like, oh, it looks like there's some sunspots. This person was probably in the sun a lot, didn't use sunscreen. I'm like, well, I guess, I guess so, but I didn't think it showed that much. And every time I put in this picture, it comes up with more or less the same thing, but the details sometimes slightly different. And a lot of it is really accurate, but a lot of it is just sort of, well, yeah, that's easy to figure out from looking at the picture. But the fact that a machine is doing it is pretty impressive. I also tried the experiment of putting white noise in there. Yeah, I think you made that suggestion in one of your comments, and that was even weirder because I just went into a GIMP and I just made up just put a noise filter over a white background, so it just came up with the hope was it was going to come up with like the prompt for what's actually going on in this. But it says it's a close-up shot of a textured surface, possibly a wall or a piece of fabric. Well, no, it's not. It's just completely generated random white noise. And it says subtle variations in tone, no discernible objects, no people present. There's no way to discern emotions or racial characteristics, ethnicity, age, economic status, lifestyle, or activities. So there's your prompt right there, or the meta prompt anyways. That's what it's concerned with. It wants to know what the emotional state of the people it sees are, what race they belong to, what's their ethnicity, age, economic status, lifestyles, activities. That's what this is all about, which makes sense because that's how you sell to people.
I think some of it's a little bit like horoscopes, though. Like some parts of it were, saying kind of broadly general things that will probably work for a lot of people. Like there was some part of reading these descriptions that really had that flavor to it. It's too generic to be stunning, but if you saw it about yourself, you'd be like, oh yeah, that's totally right. I am a friendly person who likes to go for walks on the beach.
Like the psychic reading. How did she know that?
Exactly. And so then I went to look into the API stuff behind this because, see what they're doing with this. And it's actually more interesting than this website kind of leads you to conclude. There's a bunch of different computer vision applications that Google is offering, and they're all tailored at different things. So you can get the one that's tailored to give you, socioeconomic data for marketing purposes, but they also have systems that are set up to do defect detection, like an assembly line situation or document reading or et cetera, et cetera. So I think that the information that Google in particular has about you and sells to advertisers is super creepy. Don't get me wrong, but this is the creepy product they sell. There are other ones that are less creepy as well that are also interesting. Like you could imagine using this with a prompt that asked for more just descriptive information about it that would be super useful for blind people, right? Like you could take care of the whole alt text problem where nobody wants to write the alt text for what they post on the internet, and that makes it inaccessible for people who have vision problems. If you can have a computer vision thing that describes the picture accurately enough, most of the time, all the time, That would actually be super useful for people. Or like, again, the one that's doing defect scanning on an assembly line. This is useful too. So like, there's a whole nother side to this coin that's significantly less creepy. The website's making its point. The website's making its point that these are some of the variables that people can pay money to get about you from every photo you post on the internet. And, as far as I don't even know how much they correlate the person in this data set or not, and whether Google's making that information available. I mean, there's all sorts of varying degrees of creepiness going on here. And this website's definitely pointing at the creepiest.
Yeah, and you do have to take this with a bit of a grain of salt, too, because as I just learned, I hadn't clicked through, this is basically marketing for a service for storing your photos in privacy without this kind of intrusion or analysis. They've got a vested interest in making you scared. So you'll come and use their service. Take that with a grain of salt.
All right, off to quick hacks. I wanted to start off with Durf's project, a red ring light show for your Xbox 360. Used to be that when it overheated and failed, it showed the red ring of death. Here, he's written a utility to control the 4 RGB LED segments there. And the result is a light show that goes along with Sandstorm. It's an absolutely lovely take, and it'll heal your wounds from the old red ring of death days. Next up, Ultimate 3D printed blaster does it with compliant components. That basically sums it up. This is a really sweet all-in-one 3D printable blaster, completely 3D printed, and makes use of compliant springs to shoot the little pellets out, and also a really very simple and elegant little compliant trigger mechanism. Quick one, a video by Steve Mould, pulling backwards to go forwards, the Brennan torpedo explained. This is a World War II era British torpedo that was pushed forward by pulling backward on it on a rope that spun a little trommel inside that spun the propeller. And the question is, how did this work? The short answer is gear ratios. And last but not least, Squeegee Fish's first SAO project ever, building the spectacular Fibonacci 128 simple add-on. I got to see this at SuperCon. This is a phenomenal first SAO. It is 128 RGB LEDs packed into a 1-inch diameter kind of Jason Kuhn Fibonacci style display. Absolutely beautiful. This thing was so bright in person that you couldn't look at it. He had to dim it so you could even see the thing. And when he had it on full, you could feel the heat with your thumb because these LEDs were packed so tight that it was actually, after a few seconds, warm enough that you could tell. But a really sweet piece of engineering. He ended up having to put a little daughter board on the back to take care of the power draw. I know everyone who saw this in person was astounded by it, so thanks to Squeegee Fish for writing it up.
All right, my first quick hack is Wago Terminals make this ham radio dipole light and packable. This is by Ham Radio Dude, and Ham Radio Dude likes to do SOTA and POTA, which is summits on the air, parks on the air, that kind of stuff. It's a mix of hiking and ham radio activations, and the big thing about that is the equipment has to be small and light and fairly rugged. And so he came up with this design for an antenna feed point, so a match between the coax and a dipole antenna that uses Wago terminals and incorporates a little ferrite current balun, puts it all into one tiny little package that you could probably lose in the bottom of a pack if you're not careful. Very clever design. Got a few features to make sure that it's mechanically sound when you hang it in a tree, and you can probably just build this in bulk for a club or something like that. Next up, why NASA only needs pi to so many decimal places. How many decimal places? 15. That's the answer. Why only 15? They did the math and figured out that at interstellar range, 15 digits will actually result in an error of only a couple of centimeters over the distance that Voyager is from Earth at the present moment, which is about the farthest away you're going to need to measure anything and navigate in space. So pretty simple explanation, but also pretty fascinating that they don't need to go out to any more than 15 digits. And finally, wrapping up is Catching the View from the Edge of Space. This was a project that was sort of an add-on to another solar observatory that went aloft on a helium balloon. It went up to the stratosphere, and there was a big telescope that tracked the sun. It needed to continuously look at the sun over a long period of time, so they launched this from the far northern hemisphere and in the summer, so the sun never set. But they also needed to kind of keep an eye on things on the platform, and this team came up with a 4 GoPro solution where everything was monitored by these cameras, sort of engineering data, but also really, really cool video of the entire flight, the descent, the landing, and all of the important bits of the technical part of the flight. Really cool videos. You need to check them out.
Well, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week, I wanted to pick Lewin Day's Why Did Early CD-ROM Drives Rely on Awkward Plastic Caddies? This is a really neat write-up of a technological period that I didn't even really know about. But back in the day, there was a small window of time where CD-ROMs used to come in plastic caddies with a little openable, think of one of those old, not quite floppy diskettes with the little sliding shutter that protects the plastic spinning magnetized disc. You got the right idea in mind. And the question he's asking here is, why did these things exist at all, and why did they stop existing? And how was it that this was only kind of a 3 or 4 year time period? Part of the answer is certainly that back in the day, the data that was stored on CD-ROMs was valuable enough that for some applications you would certainly want to have it encased in something that keeps it free from scratching. And so he mentions a couple use cases like, an expensive encyclopedia application, or also for music, if disc jockeys are slamming these things into and out of players all day, they want them to be not easily scratched. And so, there was kind of a time when a scratch on a CD would have mattered. Flash forward a few years to where CDs became so common and so commodity that nobody was worried about them getting scratched particularly. And, if they did, you just buy the album again for $15, I think this was a solution that had its moment in the sun, but then faded away. What's also interesting, though, is that Lewin brings up a bunch of other similar media where the cases kind of did stay. And I thought it was funny, actually, that he didn't mention the 3¼ inch floppy disk, which is exactly like this thing. But he does mention the mini disc, which was Sony's little portable, rewritable CD-ROM, but it had a little cassette around it. Sony seems to love this idea of the cassette. One of his resources in writing this up was actually a blog post written by Stoic Boy, where he says that one of the reasons for these cassettes was that at the time, the mechanism to do a front-loading CD was kind of an unsolved challenge. And if you had to install these CD-ROM readers in computers where you couldn't open up the top like you could on a Discman, that was a problem. And then once they solved that mechanical problem, there was no need for the cassette casing anymore. And I can see that. Lewin mentioned that this case design also harkens back to a previous format, the capacitance electronic disc. And I went to look this thing up, and boy, did I fall down a rabbit hole. It was apparently RCA had a system that they developed from 1964 until it came on the market in 1981. And it was eventually under the trade name Selectavision. And this was their capacitance electronic disc. And it's kind of the weird hybrid of a CD-ROM where it's using pits in a film to encode the data with a vinyl record. Because the thing actually had a read head that went along in a groove, but the read head was bigger than the pits. And so it was just sensing the difference in height between, bits that were close to the read head and bits that were further away from the read head as it slid over them, kind of like a sled along the groove. And so it was able to pull off about 100 times more information density than on a record, because the head doesn't actually have to move up and down, or in the case of a phonograph record, back and forth to read the wiggles. There was no actual physical motion corresponding to the data. It was just reading capacitive differences from the conductive vinyl being closer or further away from the read head. The read head was in the groove, but it wasn't bobbling up and down with the little pits. And so it could get a much higher information density. And these things, of course, if you get dust in your little grooves, like with any record, it throws it off. And if you want this to be a high reliability data storage format, you can't have dust in it. So these things came in cassettes, and maybe that's part of the lineage and part of why they came in these plastic caddies as well.
Yeah, I don't really remember these caddies. I certainly remember 3.5-inch floppy disks, and I kind of see you mentioned Sony seemed to be kind of in love with protect their media. And I get that because they had, the Betamax cassettes had a Flippy Door on them, and their U-matic 3/4-inch cassettes, they had a bigger, beefier door. VHS had the same thing, those Flippy Doors on the tapes, and I get that. That's important to protect those the surfaces. So, to some degree, was this just sort of engineering inertia that that just was the impulse to protect the medium, even when it didn't necessarily need it? Or was there maybe a little bit of gee whiz to it? Maybe this market's better if we have a cool little cassette that makes it look more complicated than it really is. If you just got a piece of a round piece of plastic with a dime-sized hole in the middle of it, does that register as something that you should pay a lot of money for? Or would you rather have it in a little caddy to show how precious it is, and that that justifies its extreme cost that we're gonna exact from you? I don't know. Maybe there was marketing involved in it too.
Yep. And for all those kind of intensive use professional cases, like the disc jockey example, or if they're for libraries, right? If somebody's putting the encyclopedia disc in the computer all day, 50 people a day in, day out, it's going to kill any normal CD. So maybe it does make sense. I don't know. You might be right. It might have just been in the engineering mind that this was the way you protected a disk with a lot of data on it. Maybe you just put it in a plastic case with a little metal shutter. And then so it took consumers and it falling into the hands of music lovers out there to say, hey, these machines are too expensive. We won't be able to, or was it the music industry who was like, we're not going to be able to sell records if everybody has to pay for these expensive cases.
My choice this week for a Can't Miss article is Tech in Plain Sight, Table Saw Safety by Al Williams. This is a subject near and dear to my heart. I vividly remember my dad was a woodworker for most of his life, but most of the time after he retired, he was actually in business. I remember being in college. I was just heading down to dinner, and I get a phone call from my mom. She's panicked on the end of the line. Dad cut his arm off in the table saw. Like, what? She said, Dad cut his hand off in the table saw. Like, Mom, what are you saying? It was his arm, now it's his hand. Well, it's his finger. Like, he cut a finger off? Well, he cut the tip of his finger off. So it went from the shoulder to the tip of his finger in the span of about 30 seconds, which is good, but he still did, nip his finger in the table saw and managed to cut off enough of it that you can still see it this day is one of his fingers is shorter than it should be. He took it like a champ. He bandaged it up, and they went over to the emergency room, and they were like, yeah, okay, stitched it up, and everything was fine. He didn't, it wasn't anywhere near as bad as it could be. I've definitely seen people, just straight up lop off a finger with a table saw. Table saws are terrifying devices in a lot of ways because they're extremely powerful for to be able to do the job they need to do. The margin of error can be very, very small with a table saw. You really are taking your life in your own hands when you use one, and you have to keep that in mind, and you have to be very respectful and very mindful when you're using one. However, mistakes happen. Even somebody who's used a table saw for decades at that point, like my dad, can make a tiny, tiny mistake and get your thumb sucked into a saw blade, and the saw blade ain't stopping. Which was why when SawStop came out with their technology to instantly stop the blade and mitigate the hazards of table saws, it was so exciting. I remember the ads that came out, and I was like, well, I got to get me some of that. until I saw how much they cost. SawStop, anyways, that technology, everybody's probably familiar with it, but basically what it does is there's a cartridge that the blade goes in the cartridge, kind of a semicircular cartridge that has aluminum pads that explosively impact the blade and kind of pinch it shut in an instant, and also a block that that comes up and hits the teeth of the blade and just sort of digs in, and then the blade also drops down below the surface of the table. And this is all triggered by a capacitive system that works by detecting some sort of electrical changes between the table and the blade when you put flesh in the path of the blade, when something fleshy touches the blade. But we also know that these saws do trigger sometimes unintentionally when, well, the demonstration is perfect because nobody really wants to demonstrate this with their finger, although I have seen that done. People generally take a hot dog as a proxy for a finger and try to, jam a hot dog into the spinning blade, and the cartridge fires, stops the blade, drops it down below the surface of the saw, and the hot dog comes out with nary a nick. It's very impressive, but it also can misfire based on wood that's too wet, or if you're cutting something that has a nail in it and the blade hits the nail, it ruins the blade in the process. It ruins the cartridge. The cartridge needs to be replaced. The blade is shot at this point. But the thought is, at least you still have your finger. The big problem that people seem to have with SawStop is they've been very, very aggressive in their support of their patents. They've got patents on all of this stuff it's kind of like the pharmaceutical companies with the patents. They keep managing to extend them a little bit. So I get the problem here. I'd like to see these patents open up. I would like to see, or like to see this come off patent so that other companies can do the same or better. There are probably better ways to do this than how SawStop has managed to, but nobody's allowed to figure that out because SawStop's going to come and knock on your door with lawyers. So it's kind of a bad situation, but
definitely suboptimal for the world, right? Like, it would be much better if all the manufacturers had a system like this in there, I think. But you mentioned also the prevention of the problem, and I wonder if that's not the right way. So I'm on all sides of this. I have in my basement a table saw that I made myself, and it's made out of a handheld circular saw, up mounted. I actually built a little frame for it, and it sticks out of a kind of adjustable frame in a table I made myself. And the whole thing is ridiculously janky. It's just a giant spinning blade. And that thing is so terrifying that I am entirely careful around it. Long story short, in my basement is the world's most dangerous table saw, like more dangerous than anything anyone has ever seen. And I went to a really great woodworking safety course here in Germany, and they are serious about it. And this was a fantastic table saw that, in addition to a really good riving knife, and the guy was like, he had us lean the board like sideways into this riving knife, basically. And it wasn't kicking back at all. It was the best demo. And like, if I did that at home, I would be dead within a second. But he could do it because, it wasn't going to bind on the backside of the blade. But it also had a thing that went down over the blade that also had an integrated vacuum and dust collection system in it. But it rode up on the piece of wood. So there was essentially no blade exposed. And this thing was so idiot-proof. It was amazing. Like, you didn't have to pay attention at all. You could just feed wood through this thing day in, day out, and it would be fine, and your fingers would be fine, because the little, riding sled shoe thing was up over the top. There was no exposed blade there. It couldn't kick back because it had a really, an appropriately sized riving knife at the back. And so on the other hand, I guess I see that it is also possible to make a table saw so safe that you wouldn't need this crazy, I'm going to throw a chunk of aluminum into it and make the blade fall out, emergency detection system. There's definitely a reluctance, I think, among possibly macho woodworkers to use these systems that cover up the blades because it gets in the way or whatever, or to use various push tools, push rods, or those clamp over the top pushy things to keep your fingers out of harm's way. And I do understand that it's a tiny bit more awkward, but you get to keep your fingers.
That's a bonus. Yep.
So I do wonder if there isn't like an ounce of prevention here that isn't worth a pound of cure as well.
And that was the thing that stuck with me when my friend actually cut off his finger. He was giving me a post-mortem on it and telling me everything that happened. And he said, just before I made that last cut, I said, it was the end of the night. I was working late in the shop. And I said, just one more cut. And that was the one. So if he hadn't, so that's been in my mind. What's my state of mind when I'm using this tool? Am I tired? I have a rule, no power tools after 7 p.m. because I know I'm going to be tired. I know I'm going to be doing something stupid. As it's just, I'm not at my best at that point. It's kept my fingers on.
Friend of mine with an awesome holography setup, we were talking about this the other day. He had a rule, no class 4 lasers after 10 p.m. That was his rule. It's exactly the same thing, right? It's like that's where you're going to make a careless mistake when you're tired like that. And I do, if you're a skier, everybody blows out their knee on the last run of the day. That's where you have the accident.
Naturally.
The ski lifts close, and that's where you're going to take that one last one where you're too tired and you're going to, but you're still all pumped. You're going to take that one that breaks your knee. And they're just all of these classic kind of human character flaws as well. That do we need a machine to save us from ourselves? Maybe we do. Could we do a lot by just being smarter? Probably we could. That does it for this week's Hackaday podcast. Thanks a ton for listening. If you see anything cool or do anything cool, drop us a line, tips@hackaday.com. And if you want to follow all of the links we mentioned here, head on over to the show notes, hackaday.com/podcast. And until next week,
keep on hacking. Go fetch. Is it in this week's or last week's?
It's in this week's.
I don't see the file.
It's easier to find if I remember to upload it. It's on my hard drive, though. I don't know why you can't see it.
Good enough?
Yeah. I'm not a lawyer. This is not legal advice.
Don't quote me on that.
I wish there were a verb for lithography. Lithographizing. Man versus table saw. And he will never work late in the shop smoking dope ever again.